Welcome, my dear students in secondary one. Let's start our geometry lessons. Today we will discuss lesson 1, similarity. We studied similarity before in prep 2, and we said that if we have two polygons M1 and M2, the two polygons are said to be similar if their corresponding angles are congruent and the length of their corresponding sides are proportional. Okay, in this case we will write polygon 1 and polygon 2 in the vertices of the two polygons in the order that the corresponding angles are equal and corresponding sides are proportional. And we say that M1 is similar to the polygon M2. So the polygon M1 is similar to polygon M2 if their corresponding angles are congruent and their corresponding sides are proportional. Okay. Here, for example, we have two polygons. As we can see here, angle D equals to measure of angle L, measure of angle X equals to measure of angle A, measure of angle B equals to measure of angle Y, and measure of angle C equals to measure of angle Z. And FAB over AXY equals BC over YZ and equals CD over ZL equals DA over LX, we said that the polygon ABCD similar to the polygon XYZL. Look at here, ABCD, I start from angle A and angle A equals to angle X, then angle Y which is equal to angle B. So ABCD will be equal to XYZL. When we write the similar polygon, we prefer to write them according to the order of their corresponding vertices. It will be easy to get the proportional sides. Okay, so here for example we said that polygon ABCD similar to polygon XYZL. It means that angle A equals to angle X, angle B equals in measure to angle Y, measure of angle C equals measure of angle Z, and measure of angle D equals measure of angle L. And also we say that AB over XY equals BC over XZ equals CD over ZL, and also AD over XL. Okay, so AB over XY equals BC over YZ equals CD over ZL, and L also equals to AD over XL. They are equals, they are all equals, and they are equals to K. What do you mean by K? This is a similarity ratio or the similarity scale or the scale factor of similarity. Okay, so the ratio between the corresponding sides are equal and equal to a constant number, which is the ratio, the similarity ratio or the scale factor. Okay, and K always greater than 0. If the scale factor of similarity of polygon ABCD to polygon XYZL is K, it means that the scale factor of similarity of the polygon XYZL to ABCD is the reciprocal 1 over K. And also we studied that if K or the similarity ratio is greater than 1, it means that M1 is an enlargement for or of polygon M2. Okay, and in this case we call K enlargement ratio. If K greater than 0 but less than 1, it means that polygon M1 is shrinking or minimizing to polygon M2. And in this case we call K the shrinking ratio. What about if K equals to 1? If K equals to 1, it means that the corresponding sides are equal, so the two polygons are congruent. So polygon M1 is congruent to polygon M2. Okay. So in order that the two polygons are similar, the two conditions should be verified together, not only one of them. So the verifying of one of them is not enough to be similar. Here, for example, in each of the following, show which of the pair of polygons are similar. Okay, here, are they similar or not? Here we have angle X equals to angle D, angle Z equals to angle B, angle L equals to angle C, so angle A equals to angle Y. What about the sides? Are the sides proportional or not? Let's see. The angles are equal, so let's check the sides. Okay, xy over dA, here x, y, the corresponding side is dA, so xy 4.8 and dA 4, so 4.8 over 4. Okay, what about yz? This is yz. Yz is corresponding to AB, so 3 over 2.5. If we calculate them, and 3.6 over 3, this is ZL over BC, and XL over DC, if we calculate the ratio, it will be 1.2, so this is a constant number. So the two polygons here are similar. So check angles, then check the proportion of sides. So XYZL similar to DABC. What about this rectangle? Okay, here we have the corresponding angles are equal because in rectangle all the angles are right angles. But let's see the ratio between sides. Here, for example, the length over length 8 over 6. It will be 4 over 3. What about width over width 5 over 3? So they are not equal. Okay. 6 over 8 doesn't equal to 3 over 5, although the angles are equal. Okay, and we said that the two conditions should be satisfied, not only one condition. Here the corresponding angles are equal in measure, but the ratio between sides is not constant, not equal. This is not the same ratio. 6 over 8 is not equal to 3 over 5. So the two polygons here are not similar. Okay. The ratio between the perimeters of the similar polygons is the same as the ratio between the length of the two corresponding sides. Let's see this exercise. In the opposite figure, the polygon ABCD is similar to the polygon XYZL. This is given. Number 1, I want to calculate measure of angle X and the length of XL. Measure of angle X here, we said the two polygons are similar, so angle A equals to angle X. Okay, and angle B equals to angle Y. So this is 75, so Y equals 75. Angle C equals to angle Z. This is angle C and this is angle Z, so angle Z is a right angle. Okay, we have angle L, it will be equals to angle D, so angle D is 100. Angle D is 100 degrees. Okay, so it's very easy to get measure of angle X. We have a quadrilateral and we have 3 angles. We can get angle X because we know that the summation of measure of angles, interior angles of a quadrilateral is 360. So I'll subtract 100 plus 90 plus 75 from 360 to get the measure of angle X. Okay, so let's calculate them. So measure of angle X will be equals to measure of angle A, which is 360 minus 75 plus 90 plus 100. It will be 95 degrees. This is number 1. Number 2, I want to get a length, so I should make the proportional side xy over AD equals YZ over BC. I want XL. This is XL. I want XL. AD, as we see here, 4.2. So XL over 4.2 equals YZ. What is YZ? This is YZ is 4 over 6, which is BC. Then I can get XL. 2 multiply 4.2 over 3. It will be 2.8. So XL will be 2.8 centimeters. Okay. It will be 2.8 centimeter. Number 2. If the perimeter of the polygon ABCD equals 25.8, calculate the perimeter of the polygon XYZL. Okay, we said the ratio between perimeters equals the ratio between sides. We calculate at number 1 the ratio between sides 2 over 3. Okay, so by the same way, the ratio between perimeters will be 2 over 3. So perimeter of XYZL over perimeter of ABCD will be 2 over 3. And we said the perimeter of XYZL is unknown over the perimeter of ABCD, which is 25.8 given, equals 2 over 3. So I can get the perimeter of XYZL, which is 17.2, also centimeter. Okay. So to get a missing side, we make the proportion side. If we want to get an angle, we said that the corresponding angles are equal and get the missing angle. Another exercise, 2 similar polygons. The length of sides of one of them 3, 5, 6, 8, 10. So this is the sides of the first one. And the perimeter of the other is 48. The perimeter of the other is 48. Find the length of the sides of the second polygon. Okay, we said the ratio between perimeters equals the ratio between sides. Do you remember? Here we can calculate the perimeter of the first one. We will add the side length. So the perimeter of the first one, 3 plus 5 plus 6 plus 8 plus 10. Here 3 plus 5 equals 8 plus 6, 14, 14, 24, 24, 24 plus 8, 32. So this is the perimeter of the first one. Okay, so it will be 32. And the second one, we have the perimeter 48. So the ratio between sides, I call them A, B, C, D, E, and the other one X, Y, Z, L, M. Okay, so the ratio will be 32 over 48. Now I can get the side length of X, Y, Z, L, M. The first one will be 48 multiplied 3 over 32, it will be 4.5. The second one, 48 multiplied 5 over 32, it will be 7.5. ZL will be 48 multiplied 6 over 32, it will be 9 centimeters. LM equals 48 multiplied 6 over 32, it will be 12. And this is LM. Finally, XM will be 48 multiplied 10 over 32, it will be 15 centimeters. Okay, so we calculate at first the perimeter of the first polygon, and we have the perimeter of the second polygon, and we said that the ratio between perimeters is the same as the ratio between sides. So we get the ratio between sides, and from the ratio between the corresponding sides we can get the length we know. Okay, or the length we want. That's all about our session today. Next session we will study similarity of triangles. Okay, thank you very much for watching. I hope you have understand our session today. See you next session, and goodbye.